So I will show you a actual multimeter. So you can see here two multimeters, the one on the left, which is analog, and the one on the right, which is the digital. No, so if you notice here, we have here ACV. So this is the voltmeter to be for AC current. Okay, now this is the ohms. You have the ohm, the white one. Okay, so this is the resistance, no, or ohmmeter. We measure the ohms. Then we have here the DCMA, so milliamperes. Okay, so direct current, or we call it the DC ammeter. Okay, and here we have the DC voltage. Okay, so the voltmeter for DC circuit. Okay, now we have two probes, the positive and the COM. So sometimes it's what we call COM, no, or common ground. Okay, so red. So we have most of the time red and black. So to understand, to know that this one is positive and the other one is negative or common. Okay, and yeah. So here it's a bit actually this is for my it's not working anymore. So because I mean the knob is not working, but it's still working. Still can read, but I need to do something. So you see the the analog, no, and then this one is to adjust if your deflection is out of it's not calibrated, so you need to calibrate here. Okay, so this is a the old tester that I have, and then this one is the digital. Now if you notice, this is something new. Okay, so here we have AC. Actually this one is you have two modes. It can be DC or AC. It's very important to put first the digital multi-tester into off. Okay, before using them you need to before using this knob you need to make sure where you put this value. So okay, so maybe DC or AC. Okay, so for now DC. So therefore if this is DC, all of these values here are DC. Then if you change to AC, then this one changed to AC. Okay, and if you notice, the one in the red is labeled volt, so it is voltmeter, DC voltmeter. And then if you change here, so you have ohmmeter, and then you see here there's this one is a continuity meter. So I will show you what can it do. So it just simply would like to see whether it is okay. Sorry, in this part, this one is continuity testing. So whether the two probes are connected or there's a continuity between them. So there's a sound. So just to make sure that there's a connection between the two nodes. Then you have here frequency. Okay, so hertz. Now we'll talk about it in the last number 10. Okay, but this is frequency counter or frequency meter. Okay, and then you have the yellow one for ammeter. Okay, now milliamps, and then you have milliamps, and then you have microamps, then you have 10 amps. Okay, milliamps or 10 amps. Now you can change the range from milliamps to 10 amps, or I mean the amps range, by changing the probe. Okay, now by the way, okay, from the probe you can see 4 plug. Okay, so here this is used for voltmeter, ohmmeter, and frequency. Now it's not allowed to use for ammeter, otherwise there's a label here, danger. So otherwise if you connect it to measure ammeter, then there will be excess of current, and it will destroy the fuse of the tester. Okay, so now if you want to measure ammeter, you just simply move it either to microamps or milliamps here, or if you want or if you're measuring higher ammeter or amp rating circuit, so you need to transfer on the other side. Okay, just to make sure, you need to the first thing you need to do is when this is off, check the DC or AC, and then check your probes. Okay, those are the two things that we need to take care, especially if you're now. One thing also, if you're measuring current, you know, current can kill, no? I mean, if you remember the previous topic, so you know already that if you're dealing with current, you're dealing with your lives. So you need to make sure that you transfer here, no? Okay, and then we have farad, no? So this one is for what? For the capacitance. Okay, it can be from nanofarad to 200 microfarad. Okay, so this will be a we call this the capacitance meter or something like that. No, it's not pretty common, but okay, so this is part of the recent multi tester. So you can have more so you see the difference between analog and digital. Okay, digital is when you have digits. Okay, so let's see, for example, no, as we said, and from the last subtopic, so in the ohmmeter, so you need to start from the highest resistance. Okay, so we'd like to measure, for example, something, and for example, we see here okay, I would like to measure my ohmic value. So you see the ohmic value of my hands is around 1.62 or something like that, no? Okay, so and then if you change into lower, you want to get some resolution. So if you notice, this is 20, okay, and then I am getting 1.30 or 1.7, 1.2. It's changing because maybe my blood pressure or something, my heartbeat is moving. Now if you notice, this is around 3. Now the next range is 2 to mega ohms. So it means if I move that one here, okay, now what will happen? So if it goes beyond 2, so it becomes 1 because it exceeds the amount of it exceeds the range, not 2 mega ohms, so it becomes 1. So that's why most of the time we put the value in the highest range, highest rating of the ohmmeter. Okay, so yeah, so those so these are the two. Now there's a question of this, whether which one is better. Is it analog or digital? Okay, so we'll talk about it later. Now going back to our topic. Okay, so this is multimeters. So not only 3-in-1, but you can actually have more meters in one physical device. Okay, not only ammeter, voltmeter, ohmmeter, you can also include other meters like frequency counters. Okay,